Oh, you don't believe it, I got another update. Right, just a minute. So, I put the new capacitor in the board. Let me put a light on because it's freaking dark. Right, I put the new capacitor in. Brand new. 400 volt, 150 microfarad capacitor is now installed. Right. And then I thought, hang on a minute, I don't think I checked that other Mosfet down here, because I took it out. That's why there's big space here. Anyway, I took it out. I tried to measure it in situ first, and I thought, oh, that's not right. I got a short. It was like, yeah, it read 0 ohms. I thought, well, that's not right. So I thought, well, I have to take it out. And it took me 20 minutes to unsolder it all, to get it all out. Right. I measured it on this meter, this smart computerized meter, and guess what it said? It said that it was 2 diodes. I thought, huh? What? Can't be, because that's on the 2 diodes are on the input for the rectifier. This is this part here, right? 2 diodes. I'm thinking, hang on, there's something wrong here. Now, do you remember, I've talked about this before, about this ceramic white glue, or ceramic glue. It can go conductive when it gets old. It can actually cause a short circuit. Now, if you know anything about Mosfets, you'll know that Mosfets are extremely sensitive on the gate junction. The gate of, this is the Mosfet, it's in the module, in the analyzer right now. They're extremely sensitive to any small leakage of current or microamps, right? It could cause them to switch on when they're not supposed to be switched on. When I checked it, this component measured a diode in this direction and another diode in this direction. As soon as I saw that, I thought, that's not right. There's no way you've got a diode in series with a diode in one of these packages. So I took it out and I checked it again, and it still said it was it was wrong. And then I started examining the pins. I've taken it off now, but there was a load of white glue on there, right? See where my finger is? There's a bit still on there. There's a ceramic, there's a anti-parasitic bead on the middle leg, right? That's to stop parasitics, as in high frequency noise from interfering with the device operation. Okay, so the reason I've got my finger across it is to stop static, right? And so I'll put this back in here. Let's see, put it back in there, in the hole. Oop. I hate it when that happens. Right, put it back in the hole, press the lever down. We'll test it, see what it says. Now it reads properly. It reads that it's an NEMOS transistor with a VL. Oh, shit, will you focus? VL 3.33 volt, CG 6. That's capacitance, junction capacitance. Oh shit, it's gone off now. Test it again. Junction capacitance of 6.0.6 nanofarad. RDS on of 0.6 ohm. So that's right. This component is good. Originally, when I saw this component was bad, I went and looked it up, and I'll switch over to my computer and I'll show you what I found. Anyway, let's look at the schematic, the data sheet. That's what's important. The data sheet for this is this. 9R, zoom in. This is the actual correct type. This is the net. This is the model number of the chip, right, 9500C, that's what was on it, right. If you look at the specifications for that, this is temperature, TC temperature, 100C max, 6.8 amps. The one I just looked on eBay was about 5.1 amps, so it was this is slightly different to the one I saw on eBay. I'm just glad I don't have to order another one. It was permanently switched on, by the way. That's why it was not working, that circuit. Let's see, VDD 50 volt, VDD. Anyway, a lot of technical stuff. A lot of this is math stuff, right? And I can't do math. I'm really useless. I'm useless with math. So, drain source voltage 400 volt. That's right, because that's what the capacitor is also rated at, maximum 400 volt. Let's see, Mosfet, ruggedness, blah blah blah. So they've got static voltage, what's that? Plus or minus 20, blah blah blah, yeah. Anyway, so gate source voltage, that is static, plus or minus 20. Power dissipation 25C is 156 watt. So yeah, we had not only a bad dodgy capacitor that was gassy, we also had a Mosfet that was permanently switched on. So there's no wonder it wasn't working, oscillating or driving anything, because it was and that is 100% guaranteed that was the problem, because when I measured it on my meter, it was giving me a short circuit reading because it was turned on all the time. It wouldn't turn off.